After decades of mystery, scientists finally succeed in measuring the ferocious winds of Jupiter. For centuries, Jupiter's swirling cloud tops have tantalized scientists, promising to reveal the mysteries of the giant planet's furious winds. Now, after nearly 40 years of attempts, NASA researchers have finally succeeded in directly measuring the wind speeds in Jupiter's atmosphere. Using specialized instrumentation on the Juno spacecraft currently orbiting the gas giant, the Intrepid team was able to clock winds of up to 220 meters per second, equivalent to nearly 500 miles per hour. "This is really a huge finding for us," said lead researcher Dr. Scott Bolton of the Southwest Research Institute. "The wind speeds we've measured are absolutely mind-blowing. We expected Jupiter to have strong winds, but the sheer power and velocity we found is astounding." Jupiter's superfast zonal winds have long intrigued astronomers. Visible as alternating bands of light and dark clouds girdling the planet, it's obvious from telescopic observations that massive winds course through Jupiter's upper atmosphere. But actually quantifying the wind speeds has proven incredibly challenging. The difficulty stems from the fact that the cloud tops scientists see are approximately 50 kilometers above where the planet's atmospheric pressure reaches 1 bar, similar to sea level on Earth. To truly measure the winds, you need to have instrumentation operating under the cloud layers, explained Bolton. Prior to Juno, the only direct wind speed measurements came from the Galileo probe, which parachuted into Jupiter on a one-way suicide mission in 1995. But with the probe's brief battery life, only data from a single location could be collected. Galileo's measurement at one point on Jupiter was valuable, but we wanted to get a global picture of these winds, said Bolton. That requires an orbiter that can repeatedly fly close over Jupiter's clouds. The key technology enabling Juno's groundbreaking wind speed measurements is the spacecraft's microwave radiometer (MWR) instrument. As Juno orbits Jupiter every 53 days, the MWR can peer beneath the top layers of clouds by detecting thermal radiation emanating from deeper atmospheric levels where pressure reaches 5 to 7 bars. By tracking the motion of these deeper cloud structures, the MWR data allows scientists to directly calculate wind velocities in Jupiter's interior. In a series of close flybys earlier this year, the MWR succeeded in mapping wind speeds and directions across multiple latitudes and at varying depths. "We were all incredibly excited to finally have these measurements," said Dr. Yohei Kaspi, a Juno co-investigator at the Weizmann Institute of Science in Israel. Settling the question of exactly how fast Jupiter's winds blow has been high on the wish list for planetary scientists for decades. The revelations from Juno will provide key insights into Jupiter's atmospheric processes and internal dynamics. The data indicates wind speeds in Jupiter's equatorial region can exceed 220 meters per second, more than double the maximum hurricane winds on Earth. But even more intriguingly, the winds appear to run deeper on Jupiter than scientists predicted. High-velocity zonal flows were detected at depths expected to be relatively calm. This challenges our basic understanding of planetary atmospheres, notes Kaspi. We'll have to revise models to account for the depths and speeds we now know Jupiter's winds can reach. In addition to the powerful equatorial winds, the polar regions exhibited even more startling behavior. Here, the team found signatures of towering atmospheric waves transporting hot air and energy from the lower depths towards the poles. Imagine gigantic cyclones hundreds of miles across swirling around each pole. Jupiter's poles are nothing like Earth's, they are dominated by these immense vortex systems. And the winds extend much deeper than we thought, over 300 kilometers down. It's believed these polar cyclones may control Jupiter's prodigious auroras, generating their glow by creating electrical currents in the atmosphere. Juno's magnetometers recorded bursts and oscillations in the magnetic field near the poles, likely due to these gargantuan polar storms. Upcoming orbits will provide even more unprecedented access to Jupiter's atmosphere. Juno's unique polar orbit brings the spacecraft directly over Jupiter's north and south poles on each flyby. No other spacecraft has ever explored this region so intimately. Every pass we make reveals new wonders. Juno is truly peeling back the layers of mystery surrounding our solar system's biggest world. While the Juno team celebrates their remarkable wind speed measurements, their work is far from over. Several years remain in Juno's extended mission, with dozens more polar passes planned. There are certainly more revelations in store about magnificent Jupiter and its swirling, secretive winds.